said, today's speaker is Gary Beckwith. He's a very accomplished folk guitarist. He has always been interested in taking care of the environment, and that has led directly to his involvement with solar energy. For over 30 years, Gary has been working in system design, installation, sales, education, and writing about solar energy. He is the owner and driver of the Solar Bus, and we'll see a picture of that coming up. An educational project that has visited many schools and taught students of all ages how solar energy works. Gary is also director of the Solar Seed Project, a nonprofit organization that has installed solar energy systems on medical clinics and schools in Haiti. He is one of the original writers and editors of the Solar Living Source Book, widely considered as one of the authoritative books on renewable energy. He is owner of Long Trail Solar, a small solar installation company in Vermont, and he teaches an adult education, Solar 101. And now I would like to introduce Gary Beckwith. Welcome, Gary.
Hello, I'm Gary Beckwith. Thank you for having me. I really appreciate this opportunity to tell you all about solar energy. It's a very passionate thing for me. I've taught this Solar 101 class to people of all ages, starting from kindergarten up to college. I just want to start with a really brief story about how I got to be sitting here in front of you today. It really started when I was a sophomore in college at Penn State University, and I realized that I didn't know what I wanted to do with my life. So I took some time off from college and traveled around, and I woke up one morning and decided it would be cool to learn about solar energy. And that was back in 1988. And I found a school in Colorado at the time was really the only place you could go in the country to learn about solar energy. Now it's taught in, pretty much every university. I learned how to design and install solar systems. And from there, I went to a company called Real Goods, which at the time was the largest supplier of solar energy equipment in the country. Then I moved back east. That's when I started the Solar Bus. And I put solar panels on the roof of it, and I pulled all the seats out, and I started driving around and visiting schools. Another thing I've done a lot, I've done probably, 100 concerts that are completely solar powered. I've used that stage for not only for music, but for things like political rallies. And I've had Bernie Sanders and Patrick Leahy and whoever is the current governor of Vermont speaking on my solar powered stage. And the last thing I'll say about the bus is that there's probably more people in Vermont that know me as the Solar Bus guy than actually know what my name is. In addition to that, I did start a nonprofit organization called the Solar Seed Project. SEED is an acronym, Solar Energy Education and Demonstration. And with that nonprofit organization to go to underdeveloped countries like Haiti and Puerto Rico to install solar panels on medical clinics and schools where they don't have electricity. I've been to Haiti 4 times. And as you can imagine, most of the people in Haiti actually don't have electricity in their house. It makes a big difference to bring a little bit of solar to a medical clinic. Then I started my own solar company that installs solar panels on residential houses. That's my solar story. We're gonna move on with the slideshow now. Okay, so it all begins with what I like to start with is being conscious of what you're doing. More and more people are becoming conscious of what you're doing. When you eat food, you think about where the food came from. And when you plug something in the wall, you think about, well, where did this electricity come from? We all plug things in and use electricity all the time. And it's important to think about the effects of the choices that we make. In our country, currently, well over half of the energy sources for the grid come from fossil fuels. Now, this is not going to be a class on global warming or a debate on it. I will just say that it is a scientific fact that global warming is real. The temperature of the planet is increasing. And we know for a fact that it is caused, at least in part, probably majority, by human activity. This chart shows the concentration of carbon dioxide in the air since 1960. As you can see, it's going up. And I think it's kind of interesting. If you look closely, you can see how it's going up and down every year. The Earth actually breathes. Between the seasons, the concentration of carbon dioxide goes up and down. Nonetheless, it's definitely going up. The smart people, the scientists, have determined that in order for our climate to stabilize, we need the concentration of carbon dioxide, and that's in parts per million, to be at 350 or under. Now, when this slide was prepared, it was obviously a little under 390, so it was too high back then. This slide is a little outdated, and if you look it up right now, I think we're at like 440 or something like that. Basically, this trend has continued, and that's a really bad thing. So one of the solutions, and there's not any one single solution. There's no one thing that's going to save us all, but one of the solutions is solar, because it is a way to produce electricity that does not involve burning any fossil fuels or putting carbon dioxide into the atmosphere. This was one of the very first utility scale solar applications. It's called Rancho Seco. It's in California. So throughout my presentation, I like to throw out little factoids and things like that. And this is one of them. Think about this. Every 10 minutes, enough sunlight reaches the earth to create all the electricity that is used by the entire planet in a whole year. So don't let anyone ever tell you that there's not enough sun or there's not enough solar panels or something like that to power the planet. Basically, we're constantly being bombarded with free energy, and it's all just a matter of harnessing it. Okay, now this map just gives you an idea of the different parts of our country and how much solar potential there is. People think, oh, I live in the Northeast, so solar isn't practical. But the sun shines everywhere on the planet, and it's all just a matter of math. And it's true that the sun shines less in some areas, but all that means is to make the same amount of power, you would need a few more solar panels in the Northeast than you would in the Southwest. You can still do it, it just costs a little bit more. We're going to start with how are solar panels made, because this is really important. Anytime we have a solution to a problem, we want to make sure we're not creating other problems. So there's a few different types of solar panels. The most common type of solar panel is what we call a crystalline solar panel. It's the exact same technology basically that was on those solar panels that you saw on that array at Rancho Seco that were put there 50 years ago or more. They've gotten a little more efficient over the years, but it's the same technology. There's other types of solar panel material that are promising. You might have seen solar panels that are flexible, you can roll them up and things like that. They call that amorphous silicon as opposed to crystalline silicon. They're not typically used in residential and large applications because so far the amorphous silicon types of solar panels tend to degrade more over time than the crystalline panels, and they're less efficient, which means that they take up more space to create the same amount of power. So someday it's probable that we will be using a different type of material to make solar panels, but currently we're using crystalline silicon and it works great. One thing I want to say from the beginning, we are not waiting for like some breakthrough for solar to become practical or economical. It is practical and economical right now. And there's no reason for us to wait for them to become more efficient or anything like that. And hopefully by the end of this presentation, you'll understand why that's a true fact. So where does crystalline silicon come from? It actually comes from sand. And unfortunately, it's not just like any kind of sand. You can't just go to the beach and make solar panels. It's a special kind of sand, but sand is one of the most abundant things on the planet. And it's just basically kind of like a really pure kind of sand. That basically they melt sand and they grow crystals from the melted sand. This is an uncut crystal that's being tested in a laboratory. It does come out round. And it's interesting because when you look at a solar panel, you'll see that usually the cells, we're going to get to what cells are square or rectangle. And that's because if you think about it, if you're trying to get the most amount of power out of a given space, the solar panel is usually rectangular. If you put a bunch of circles on there, there's going to be some wasted space in between each circle. But the earliest solar panels had circular cells on them, but now they're all square and they actually have to shave off the corners or the edges of the cylinders to make the square. And there is some wasted material there. Let's get down to the basics. A crystal is grown and then it's sliced. And then basically on the top and on the bottom, two different materials are impregnated on the silicon wafer or slice of the crystal. The two materials are phosphorus and boron. So what happens when the photons, which come from the sun, and a photon, by the way, is actually a particle. It's not like a wave of energy. There's particles of energy that are coming from the sun. And when they hit the photovoltaic cell, a cell is the slice of the crystal with phosphorus on one side and boron on the other side. My mom said everybody's really smart here, so I don't have to remind you that in 6th grade, we all learned about atoms and electrons and everything. So when the electrons are going around the nucleus of the atoms in the cell there, and when the photons from the sun strike the atoms, you probably remember also that there's this thing that can happen when electrons get excited. So that's what happens. It excites the electrons, and when electrons get excited, they want to jump off. If you have a cell just sitting there, there isn't really any place for the excited electrons to go. So we basically just put some wires on the top and on the bottom of the solar cell, and it provides a place for the electrons to go. This is the most simplest type of a solar system, where you just have one cell and you're going from the bottom to the top and you're creating a loop here. And basically, if you didn't have a light bulb there and the sun was shining, you'd have all these electrons that would be just going around in a loop like that. They call that short circuiting. The most simplest type of system is to just put a load or an appliance right in that circuit. And in that type of system, whenever the sun shines, in this case, the light bulb will come on. When a cloud goes by, the light bulb will turn off. Now, that's not very practical, because every time a cloud went by, all the lights went off and our computers went off. That would not work very well. So we add things to the system. It used to be that we added batteries to the system. So then when a cloud went by, or at night, because the sun goes down at night, we use energy that's stored in the batteries during the day. So we have basically an uninterrupted supply of power. Today, instead of using batteries, we use the grid as kind of our battery, virtual battery. And instead of storing the energy in the batteries, if there's extra power, it goes into the grid. And that way, also being connected to the grid, when a cloud goes by or at night, we can take power from the grid. Okay, so this is a typical solar cell that you see today. And I mentioned before, you'd usually see these rounded corners, and that's because the original crystal that was grown was cylindrical. These are some cells coming off the manufacturing line. So, all right, so I mentioned a cell is one of those, a slice of a crystal. Now, when you take a bunch of cells and you wire them together, we call that a module. And when you take a bunch of modules and you wire them together, we call that an array. So we have cell, module, and array. Now today, a lot of people have solar panels on the roof of their house. There's a lot of other applications of solar too. And one of those is, like I mentioned before, I've gone down to places where people don't have electricity at all. And just having like one solar panel on the roof of your house makes a big difference, being able to have a light or a place to, charge your phone or something like that. This is me in Haiti on my first trip there, where I was putting this array on a school. And now we have utility scale projects where we're actually starting to put a dent into trying to use more renewable energy to provide the power for our country. I don't know what the exact percentage is right now, but I remember I used to wonder like if and when it would ever be like 1% produced by solar, and we're past that now. Okay, now, at this point in the class, I'm going to ask you a question. Don't worry, you're not going to be graded. If we wanted to make a solar array that would produce all of the electricity that our whole country uses, businesses, residences, how much electricity we currently use right now, we wanted to make a solar array that would produce all of that electricity for us. How big do you think that array would be? So just think of what the answer is. Keep your answer in your head, and we will get to the true answer in just a few minutes.